Now we get into the initial conditions. We always have to have something to put in so that we get this model started. We're to have, of course, the land split of the crops we're going to use. We're going to use corn, sorghum only. We're just going to have two crops we examined. We're going to put them in a 50-50 rotation. And you can see the irrigation cost, operating cost for both crops, price per bushel, the maximum yield, we just talked about that, and the annual rainfall and the system application efficiency. These are important inputs. You can skew the results by not being realistic by any of these inputs. If you want something that goes this way, put in a high corn price. If you want it to go that way, put in a high sorghum price. So, what happened? Help me out. Okay, these you have to put in and be reasonable about that. Garbage in, garbage out. So the best results are using your best estimates of those values. Now we go into the stacking process that I introduced. For the corn, sorghum crops, we look at the top option, the most net return, on through the sixth. Where on the top option, we're going to put all of our irrigation on the corn, dry land on the sorghum, and get a result like this, $138 per acre. Second, we put some water on some small amount of water on the sorghum and more on the corn and on down until we get to the situation where we're putting all the water on the corn. And this is 6 inches of water for the whole growing season, and we have 16 inches of rainfall. Now we have to put our thinking caps on. What's going to work might work for me. If we go to the option number one, we're going to have dryland sorghum. Is that a risky business to get into, to have dryland sorghum down here and completely dry land from year to year, and we have continuous cropping? Or on the other hand, we go on to spreading all of our water over the whole cornfield. That's 6 inches of water. Is that risky for you? Or do you come somewhere in between, put a little bit of water to keep that sorghum going, but put more water on where the corn will respond to that? Now let's take that top option and try to examine it just a little bit more. And we're talking here about if you have more irrigation available to you than the 6 inch, still 16 inches of rainfall, you're able to add more irrigation to see how things change. So number one option was the top line, start adding irrigation on. And we switch over to continuous corn, no sorghum at the 10-inch level, and getting more net return and up to 12 inches then when you have the 12 inches of irrigation. Very large impact on your net return, your bottom line. Then we look at a two-way comparison with the corn and sorghum, and a little bit more examination of that option number one, and we go in and put in a variable there for the corn price and the sorghum price and see how they line up on a two-way table. When you increase one against the other, what's your net return? What I was saying before, you juggle those commodity prices and you're going to get a large difference in the outcome. So you want to be, again, realistic. It's not the market price today, but what you think the market price is going to be over the longer haul. We're making a longer-term decision. We can do a two-way analysis of developing these tables for any combination of these outputs or inputs that you put in. Commodity prices, we just looked at them. Production cost, maximum yield, precipitation, irrigation cost, and application efficiency. So if you're anticipating making a change or might see what the results of this change might be, well, let's look at a two-way table, and we can do that in the program to examine those one against another to see what the results are. You may be looking at, say, a big increase in irrigation costs. How might that influence the other outputs? So another thing we can do, we talked about the risk before, and we see our, in this case, we have 6 inches of irrigation water, back to that 6 inches, and we have this range of precipitations. A very dramatic net return situation. And as we go through the more precipitation, we're going to tend to go from the corn sorghum situation up to the continuous corn, which with 20 inches of irrigation, yeah, that's pretty risk-free. So if we could have that every year, well, we'd be happy, but that's not the case. Now, change your thinking completely. We've gone through an analysis of what crops we might select, how much water to apportion to those crops, and I'm thinking about what's going to happen this year and how can I best use that water and project my irrigation schedule through the next year. So the questions we ask in that situation, we have a low capacity system, is do I pre-season irrigate? Do I stretch that irrigation system out farther with low capacity, or do I just wait and hold that water for the growing season? When's the first irrigation during the growing season? That's maybe we'll be trying to accumulate water in that root zone. We may not need to do that. Do we need to hold off the water? Do we need to stop or start earlier? Looking at the irrigation frequency, this is dictated by the system capacity and also how much irrigation you really have allotted to you. Then what's the last irrigation? And what the exercise here is predetermining an irrigation scheduling and see how the yield responds, again, back through our crop modeling approach. First thing we think about is where are we starting with that soil water? And if we look clear back at the preceding October after harvest, I'm going to run that example where we have a dry condition, a moderately good condition. This is good management, ending up with half the water left after your growing season, if you can do that, or really a pretty full profile. Now, I compare this with 2009, 2010 for us, we were up to 70%. 2010 going in 2011, we're probably closer to the 30%. So we can see that years make a difference, and you can always go out in your field in March and April, take the same readings, type of readings, crank those into the model, and it'll give you go forward. The closer we get to the actual growing season with our measurements, the better they are, and the influence of on that growing season. So as we go across there, we see the relative yield again, net return, the effective ET, that's the water that went through the plant or out the soil surface to actually the E or the T on that really contributed to the yield. And then the non-ET losses, that includes drainage or evaporation during the non-growing season. That's the water that got away from us. And yes, we have losses, and a lot of that is in drainage, but when the soil is wetter, it's more prone to drainage, more prone to have evaporation, so more of that water is lost, and it gets pretty dramatic when you really have that soil water profile full.